Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hammock's Middle School Earth Science Department. Today we're going to be talking about page 1 in the reference table, your radioactive decay chart. Now this radioactive decay chart actually helps scientists figure out the actual age of a rock itself in millions of years. So what they use what's called a radioactive isotope. They take an element that's radioactive and they try to figure out the percentage of the isotope compared to what we call its daughter product. So the first row on the left are your isotopes, carbon-14, potassium-40, uranium-238, and rubidium-87. The middle row is all about the daughter product, what these things are going to change into, given enough time. And then finally the half-life, how many years it takes for half of your isotope to change into its decay product. So the first one that we're going to focus on is going to be your carbon-14. Remember, this is going to be a very important isotope because it's found in organic material. Carbon-14, C14, changes into nitrogen-14, or the symbol for that is N14. And it takes 5,700 years for carbon-14 to change into nitrogen-14. The next isotope down is potassium-40. Now, potassium-40 actually has two decay products. Okay, it's going to change either into argon-40 or calcium-40, and that takes 1.3 billion years for potassium-40 to change into one of its decay products. The next isotope is uranium-238. The U-238 changes into lead-206, and it takes 4.5 billion years for uranium to change into lead. And then finally, your rubidium-87. The Rb-87 is going to change into strontium-87, and that takes 49 billion years for rubidium-87 to change into strontium-87. So it's a very simplistic chart. Just realize that your half-lives are in years, even though it's in exponential notation there. You have to be able to expand out the values of your half-lives. And with that being said, thanks so much. We'll talk to you soon.